Now we're going to look at angles in a circle. I'm going to try and make this as neat as I possibly can and then see where we go from there. Now when we consider a circle, there are many lines that we can find operating in a circle. So long as we know where the center is, that's my center, I'm going to call it O. If a line goes through the center of the circle, then this line is called the diameter. But you need to make sure that that line is actually going to touch both sides of the circumference there. If the line, however, just goes from the center to the circumference, this is known as my radius. So I'll label that radius. It's really clear from this as well that double the radius gives you the diameter. If, however, I just draw a line just cutting the circle there, but it doesn't go through the center, this line is called a chord. So if I'm using these terminologies in what I'm saying, then try and remember what these things mean. And the nice thing about a chord, well, the chord divides the circle into, which is what I'm shading here now, segments. Because this is a small segment, it's called a minor segment. And obviously, the bigger side is called a major segment. One last line I will talk about now, and that line is going to be a line that just touches the circumference of the circle, and this is called a tangent. Now, thing to know straight away, if your radius or your diameter comes and touches exactly where the tangent touches the circle, it makes a perfect 90-degree angle. And that's a rule for us to try and remember throughout this course. And knowing that, that's going to really help us to do some pretty tricky calculations when it comes to operating with angles in a circle. Of course, you need to know a little bit about triangles as well, but we'll take for granted that you already know that. Now let's look at a couple of examples of places where we might need these skills in order to solve problems. So here I have a circle. Then I have a tangent running across there, it's not quite touching, a radius coming down here, and then another line going across there. In here, I have 62 degrees there, and I have an angle A I need to find in the corner here. Well, straight away, from the previous page, we know that as soon as the tangent and the radius makes contact at that point, it makes a 90-degree angle. And because we already know all the angles of a triangle add up to 180 degrees, it's quite easy to find A, which will be 180 degrees, take away that 62 degrees plus the 90 degrees we have in the corner there made by the tangent and the radius. And after a quick bit of calculation, we've got 28 degrees is angle A. Now we'll just look at one more problem with this, and then you can have a go at trying some for yourself. So now, looking at our second problem, this is what it looks like. We need to find the angle D, which appears at the center of that triangle. Well, few things we can figure out straight away before we get going. Because this line is the radius and that line is a radius, the same radius of the same circle, it makes an isosceles triangle. With that being said, we know that this angle and that angle are both the same. We also know from our rules on the first two pages that this radius makes a 90-degree angle there with the tangent. thereby giving us one of the little angles in the isosceles triangle as being 90 take away 60, which is equal to 30 degrees. Now we're on to finding D, because now when we look at the isosceles triangle, we know that that same 30 degrees is also there on that triangle. So we can therefore say that the angle D is equal to 180 degrees, all the angles add up in the triangle, take away the 30 degrees plus the other 30 degrees, thereby giving you 60 degrees. Angle D is going to be 120 degrees. And that ends the problem today. Have a look at some other problems generally along similar area and see how much fun you have finding missing angles for triangles in a circle.